Hi, welcome back to our honors geometry videos. In this video, we're going to talk about our areas of similar figures. So if I have a scale factor between my pre-image and image, we'll always call here, in this first part, the pre-image on the left, image on the right. So that's just for this first part, questions 1 through 3. I'd like you to find the scale factor of each set of similar figures, and then find the areas of each one, and see if you can find a pattern between the areas, or the relationship between the areas, and the scale factors between the two figures, the pre-image and the image. So if you want to take a few minutes, pause the video, and then try that, and unpause when you're done, that would be great. Alright, so here I've got an area of 10, area of 40, and my scale factor from 5 to 10 or 2 to 4, the scale factor would be 2. Here I've got an area of 1 square unit. Here I've got an area of 9 square units, if that is a square. And here I have an area of 36 pi and an area of 324 pi square units. My scale factor here is 3, and my scale factor on number 3 is also 3. So let's see if we can identify the relationship there between the scale factors and the areas. And it looks like here the scale factor, if I take that scale factor and I square it, that would be the ratio of the image over the pre-image. So 2 squared is 4, 10 times 4 is 40. 3 squared is 9, 1 times 9 is 9, 3 squared is 9, 36 times 9 is 324. Now, why does that happen? Well, if I were to draw, I'm going to redraw those two rectangles. I'll go 10 and 4 and 2 and 5. Well, what's really happening when I scale this up? This area is 5 times 2. And I can rewrite 10 as 5 times 2, and this was 2 times 2. So my area here, because I multiplied each side by 2, the base and the height both got multiplied by 2, or it got multiplied by 2 squared. So here I have 5 times 2 squared. So that's why we get the 2 squared, or the scale factor squared. And if two polygons are similar, then the areas of the polygons would be proportional to the square of the scale factor. So you could say that the why did I put area, or P? Area of the image would be equal to the area of the pre-image times the scale factor squared. Or you could say that the area of the image over the area of the pre-image would be equal to the square of the scale factor. Let's look at some examples. If these are my two triangles, they're similar. That has an area. Okay, that crashed. My triangle JKL has an area of 30 square inches. And I want to find out what the area of the triangle PQR is. Well, first thing I should do is I should find the scale factor. So I'll find the scale factor between the two. And that should be, if we assume pre-image an image, if we assume it's an enlargement, would be 1.25. So then if I wanted to find the area, I wouldn't multiply the area of the preimage by 1.25. I would multiply it by 1.25 squared. And the reason, again, why we're squaring is because if I'm multiplying both the base and the height by 1.25, it's getting multiplied by 1.25 twice, or I'm multiplying by 1.25 squared. Another way to remember this is that your areas are always in square units, so your scale factor needs to be squared. And lastly here, if I'm finding the area of the similar figure, I'll call that, let's go with 40 and 10 again. If I call that 40 and 10, then what I need to do is I need to find the scale factor to find out what x is. But all I have is the area of the image. And that would be the area of the preimage times your scale factor squared. So if I substitute in these numbers, we'll call 40 the image, equals 10 times your scale factor squared. Then 4 would be your scale factor squared. So your scale factor, what squared makes 4? Well, that would be 2. So your scale factor would be 2. But I'm not done yet. I know the scale factor. I still need to find what x is. So if my scale factor is 2, then x must be 5. And another one here, a good one to pause, try on your own, and then unpause. I've got this area of a side of the skyscraper is 90,000 square feet. The scale model of that same skyscraper, the area is 200 square inches. So first thing we should do is we should convert, and then I'd like you to try to find the height of the scale model on your own. So here I know that my area is 200 square feet, or 16.67 square, or I'm sorry, it's 200 square inches. It's 16.67 square feet. So to find my scale factor squared, that would be equal to 90,000 over 16.67. And that gets you like 5,000, let me check, 90,000 divided by 16.67. That gets you 5,398.9. But that's your scale factor squared. And I don't want scale factor squared, I want your scale factor. So I need to find out what is the square root of that. And it turns out your scale factor is about 73.5. So if my scale factor is 73.5, I can use that to find the missing height of my scale model. So 720 divided by 73.5, and we get about a height of 9.8 or 9.75, 9.76, 9.8, I'm sorry, 9.79, 9.8. And that would have to be feet. Now, it didn't ask us for the height in any specific dimensions. And if it did, we would just convert from there. Let me know what questions you have, and I'll see you soon.